Okay, everybody, so today I'd like to show you how to solve the alcohol mixture problem, okay? And when you see this problem, the numbers will probably be different than this, but I can get the concept across just fine with these numbers. Now, let's read the question, and I'll do a little bit of thinking about the information in the question, and then I'll talk about how to solve it. So it says, how many ounces of a 15% alcohol solution must be mixed with exactly 6 ounces of a 20% alcohol solution, and you mix them together and you get a 17% alcohol solution. So first of all, let me tell you some of my observations. That the first one is that I would think if you mixed a 15% solution with a 20% solution, you would get something somewhere in between, such as a 17% solution. So at least, when we read the problem, it seems like a problem that has an answer. Like that, this seems like it's something that's possible. All right. The second thing that I want to think about is that what do we mean when we say that we have a 15% solution of anything? We could say it's alcohol or hydrogen peroxide or whatever. You can mix things together and have them in different proportions to each other. If I say that the solution is 15% alcohol, that means 15% of it's alcohol and the rest of it is something else. The other 85% is water or something else, okay? But what exactly with the number 15%? What do we do with the number and what does that tell us? So let me back up and review something a little bit. So suppose that now let's say, okay, we're gonna put this problem on hold for now, and I want to talk about something a little more basic just to make sure that we're on the same page. Suppose that we have 12 ounces, a 12-ounce mixture that is 7% alcohol. Okay, let's talk again. 7%. What exactly does 7% mean? 12 ounces, so that's the volume. That's how much. And 7% is alcohol. So how much alcohol does this mixture contain? Okay, so what does the 7% translate into, in other words? So, okay, well, how much alcohol does the mixture contain? It's pretty easy to answer. We take 0.07, which is the decimal form of 7%, times 12, the total volume of the mixture, okay? And that just translates into, it's like saying 7% of 12. If we take 0.07 times 12, that might as well say 7% of 12. When you do the math, that's 0.84 ounces. There's a 12-ounce mixture, but 0.84 ounces of it is alcohol. That makes it 7% alcohol, all right? Okay, so now you know what the percents mean. You have a way to translate those and understand what the information is. So, okay, now about this one, it's, if you want to see the equations, you can see the equations and kind of imitate how the numbers go and so on. And if that's the way you want to look at it, I can't really force you not to do it that way. I would really rather that you understand how to put the equations together. You're learning a lot more if you understand how the equations come about. All right, that's what I think really could help you. Okay, so I'm going to try to convince you. I'm going to try my best to convince you how to set up the equations. I want you to really understand where they come from. So the way I see it is we're mixing two things together and we're getting like an end result. So here's the way I'm thinking about it. I have two things I'm mixing together and I'm getting something else. Did it tell me how many ounces of 15%? No, in fact, it said how many. That's what I'm looking for. And since I don't know, I'll call that X. I have X ounces of a 15% alcohol solution. I'm going to mix that together with exactly 6 ounces of a 20% alcohol solution. And I'm going to get, how many ounces am I going to get? Well, I don't know. If I mix 6 ounces with some unknown amount, I don't know how much there's going to be. So I'll have to say Y ounces because I don't know the volume of this resulting mixture. When you pour these two containers together, if I don't know how much is in this one, I don't know how much is in the mixture, okay? So, but you'll get Y ounces, Y being some number that I don't know at this time, of a 17% solution. Okay, so that's kind of how, if I wanted to envision or think of this in terms of a picture, that's how I would do it. Now it's time for the equations. Now, I see two things happening here as you mix these together. This already kind of looks like an equation, doesn't it? I'm thinking of these as like containers, but it sort of looks like an equation. So two things. The amount of alcohol in each container has to add up properly, and the total amounts have to add up properly. All right? And what I mean is that, remember, there is the amount in the container, which is 12 ounces, but then the amount of alcohol in the container is 0.84 ounces if it's 7% alcohol. So the total amount is different than the amount of alcohol in the mixture, and it's all based on the percent. So what's this equation say? Well, all right, if this is X ounces and it's 15% alcohol, how much alcohol is in this container? 0.15X. And if this is 6 ounces and it's a 20% mixture, how much alcohol is in this container? 0.2 times 6. And the amount of alcohol in this one mixed together with the amount of alcohol in this one would have to be the amount that's in that mixture, right? I mean, because you're combining these and you're getting this one. So how much alcohol is in that resulting mixture? Well, it's 17%, Y ounces, 0.7 Y. So this first equation right here says that the amount of alcohol in this one plus the amount of alcohol in this one has to be the amount of alcohol in the final mixture. That's what that first equation said. The second equation says, well, the total amounts have to add up too. So meaning, if this container has a total of X ounces in it, and this container has a total of 6 ounces in it, then this container, being the mixture of those two, has to be X plus 6 ounces. So in other words, it's like saying, if this was 1 ounce and this was 6 ounces and I poured them together, that would be 7 ounces, right? 1 plus 6 is 7. That's all that second equation says. So we get two equations out of this. Now, why we get two equations? Do we need two equations? Yes, because if there are two unknowns, we'll need two equations to solve. And so, yes, we get two equations. That makes it possible to solve it. So how do you solve this? My goal now is to work with those equations and get an answer, right? So let's look at it this way. If I do a little bit of work on these, let's say, like, what's the first and most obvious thing that we can do? Well, what's 0.2 times 6? Well, that's 1.2. So this is really what we're working with. Let's try to solve this, okay? So now, by this point, by the time we get to the word problems, we learn different techniques for solving equations. And one of the techniques is that we can sometimes sub one equation into the other. Okay, and so here's what I mean. Like, this equation is solved for y already, isn't it? Okay, it says y equals x plus 6. So I can go ahead and plug that in right there. And then I've substituted the y out of the equation. And that's what you see here. 0.15x plus 1.2 equals 0.17 times x plus 6. What's the next thing that it looks like I can do? Well, how about multiply through like this? Why don't we do that? That's a kind of typical thing that a person would do if they're solving an equation. So if you multiply through there, on the right-hand side, you'll get 0.17x plus 1.02. To solve further, we group the terms with x on the left and the numbers to the right. So I subtract 0.17x from both sides, leaving me with this number, negative 0.02x on the left. And I subtract 1.2 from both sides. 1.02 minus 1.2 is negative 0.18. Okay. So one last step, I divide negative 0.18 by negative 0.02, and that's 9. X is 9. What was x? that was the number of ounces of this 15%. Also 9 ounces of the 15%. You get 9 ounces of this 15% solution. Mix it with 6 ounces of 20% solution. And what do you get? 15 ounces of a 17% solution. Well, because 9 plus 6, that's 15 ounces. All right. So now the 9 is our final answer. That's all the question asked for, because it just said how many ounces of 15%. But if you needed to find the amount in the total mixture, that would be 15. Okay. So hopefully you get the total package out of this. We can understand the nature of the question. We can think about how we're mixing these containers together. We get 2 equations. The alcohol and the total amounts must all add up. And there we solve it like, whether it's a word problem or not, we solve it how we would solve any problem that had equations that looked like that.